Welcome back to Backspace Academy. In this lesson, I'm going to go through the Elasticache service. We do also have two labs on Elasticache, and they do go into quite significant amount of detail on how to use Elasticache at the management console and the command line interface. And we have another lab there for developers who would like to know how to program the Elasticache Redis engine using the AWS JavaScript software development kit. So this lesson will be preparing you for those labs. So first of all, we'll go through exactly what is Elasticache and the two different options that we have for a caching engine being memcached and Redis. And then we'll look at the ways in which we can enable caching on, for example, a data source or a database. Elasticache is a managed in-memory cache service. It is a key value store and provides ultra-fast sub-millisecond latency access to your cache data. There are two options available for that data store, one being Elasticache Redis and the other being memcached. It is primarily used, but not always used, to reduce load on a database. So in a similar way as you would use CloudFront to front and cache an Amazon S3 bucket or a website on an Amazon S3 bucket, in the same way that you would use CloudFront in that situation, you would use Elasticache as a cache in front of your database, and that would reduce the load on your database. It would reduce the latency on any request to that database. It provides multi-AZ capability, and you would use it in situations where there are a high request rate required. So if you need very fast access to your data and there is a high request rate for that data, you have a lot of users. And the volume of data is quite low, but it's regularly accessed data, and you require low latency to that data. The first option available to us is the memcached engine. So memcached, it's a free and open source project and provides high performance distributed memory object caching system. It only supports simple data types, and the data structure is a string or an object up to 1 megabyte. The data volume maximum that you can have in a memcached cache is 4.7 TB, and there is no persistence of data. If data is lost inside a cache, it cannot be recovered. But that is not such a bad thing, because this is a caching engine and you would normally use it in front of a database. So if you lost the data in your cache, you can always retrieve that data back from your original data source being the database behind that cache. It provides simple scaling by adding or removing nodes, and the data is distributed across those nodes. It is suitable for simple data structures, for large nodes with multiple cores or threads, and in situations where you require elasticity, where you require a scaling in and out by adding and removing nodes according to demand. And you require partitioning of data across multiple shards. And it's very suitable for caching databases. The next option available to us is Redis. So Redis is a little bit more of an advanced caching engine. Again, it's a free and open source project, and it's a in-memory data structure store, similar to memcache, but more advanced. It supports far more advanced data structures, strings, hashes, lists, sets, sorted sets with range queries, bitmaps, hyperlogs, and it also supports geospatial indexes with radius queries, which is great if you've got a mobile application, for example, that needs geospatial information. It needs location information and you just search that information. Really good. You can do that in very, very low latency. The key value size can be up to 512 megabytes, so much more than the memcache 1 megabyte. And the maximum data volume is slightly less than memcached at 3.5 TB. The data is persistent, so lost data can be recovered. And we also have read replicas for Elasticache Redis. So this is good if you want to use Redis on its own as a standalone key value store without a database behind it. it has a very large command set available. So that combined with the advanced data structures that are available, you can have very complex querying of that data and enables you to have very good, very advanced applications using the Elasticache Redis engine. It supports notification or notifications from the Redis pub sub channel. So you can set up a pub sub channel and users can subscribe to that channel and receive notifications through the Redis engine for changes to that cache. So you would use it over memcached, obviously where you would require that advanced data type, where you would require auto sorting of data, where you would require pub sub capabilities, where you require high availability and failover, you want persistent data. So that is where you would use Redis. It's a more advanced version of memcached, but memcached is still very good if you don't require all the bells and whistles of Redis. And certainly if you've got a NoSQL database, for example, and you want to put a key value store in front of that, memcached is great for doing that. In order for our caching engine to be useful, it needs to be updated on a regular basis or updated on an event-driven basis. So when data changes, we need to have some way, for example, we need to have a database trigger to update that data. So DynamoDB has database triggers and MySQL, there's a MySQL.lambda async procedure that can trigger a Lambda function. MongoDB also has built-in triggers for its databases. So if our database supports triggers, we can use that to update Elasticache using a Lambda function or using a separate EC2 instance to copy that data over to our Elasticache engine. We could also use our application itself to update Elasticache. So when our application has a read request to the database, it can also update Elasticache at the same time. There are a couple of caching strategies that we can look at for loading our data initially into our Elasticache and also for updating that data when it changes. The first one being lazy loading, and that will load data into the cache on a cache miss. So what that means is that if a request comes into Elasticache and that data is not available, then our application will go back to the data source. It will retrieve that data, load it into Elasticache, and then also at the same time return that data back to the requester. It will require a time to live to be put on that data. Otherwise, the data will grow and it will become not manageable. So when data is not accessed regularly, we need a TTL on that to remove it from the cache, because the cache is only there for accessing regularly accessed data. The downside of lazy loading is that it requires 3 trips on a cache miss. So we need to first of all go back to the data source. If the data is not in our cache, then we need to retrieve that data, put it into Elasticache, and then return it back to requester. The other strategy there is write through, and that is where our application, or if we're using database triggers, a trigger event will update the cache when data is written to the database or the database is updated. So this again requires a TTL to make sure that stale data doesn't build up. The downside of write through is that it caches infrequently accessed data. So unlike lazy loading that will cache it only on a cache miss, this caches it whether or not it has been requested. So that does require more resources, volume of data to be stored in the cache. And so it definitely does require a TTL to get rid of any stale data, more so than in lazy loading. Adding a TTL, so memcached and Redis both have the option there to, through a set command, to specify an expire parameter. In memcached, it's in seconds, and in Redis, it is in either seconds or milliseconds. So in our set command, we have an EX parameter, which is the expire time in seconds, and the PX, which is expire time in milliseconds if you want it to expire very quickly. So when that expire time is up, then it is that data, that key value, is removed from the cache. So that brings us to the end of our lecture on Elasticache. There are a couple of labs coming up. The first one being using Elasticache, which is for solutions architects and SysOps administrators. And you will go through using the Amazon console and using that to create an Elasticache Redis cache, and at the same time accessing that through the CLI. The other lab is for developers, where we are using the software development kit, the JavaScript software development kit, to program Elasticache Redis. So that brings us to the end, and I'll see you in our next lecture.